Hello everyone, hope you all are fine. Welcome to Shaurav's classes. Today we are back with another session, Tomato Problem Solving Session Objective series of videos. So if you have already seen the previous ones, then it's well and fine. And for those who have come to new, let me explain you that this series is basically for aspirants of Indian Statistical Institute and Chennai Mathematical Institute entrance examinations. And Tomato book is usually this book that is called, so Test of Mathematics at 10+2 level is the book that is published by Indian Statistical Institute themselves, and this is a very important book for clearing those examinations, as this is one of the books that is published by themselves, the I.S.I professors themselves, and they have included problems in this which are of equal aptitude as the problems that you will get in the exam. So the purpose of this book is to just familiarize with you the problems that you will be getting in the upcoming exams, the pattern of the problems that you will getting. So the type of the problems, the syllabus, the theory required that is essential to solve this problem. So this is the ultimate book that will help you to clear the examinations. So we are back with Tomato problem solving session objective. So as I have already told you guys that the I.S.I paper pattern is of two parts, subjective and the objective, in which you need to qualify for both the parts to get a call for an interview. So this subjective objective part is the first part. So in objective the rules are like this, that you have got 30 questions, out of which if you get a question correct you get 4 marks awarded. If you don't attempt a question you get 1 marks awarded for that. And if you do a question incorrectly, or if you mark the objective incorrectly, then you get a 0 mark for that. So this is the first question for the day that I have assumed, and this is from trigonometry, from the general solutions part. So the question says the number of solutions of sec x plus tan x equals to 2 cos x, 0 less than equals to x less than equals to pi is option A 0, option B 1, option C 2, and option D 3. So what you need to do is you need to basically find the number of solutions of this equation, and I give you some stipulated amount of time to solve this problem, and then I'll come back to the solution. Okay, so the stipulated time meant for this question is over. So this question is not that tough as it looks like. So if you have a bit of knowledge of trigonometry, then you can easily solve it. And for those who cannot solve it, I'll just demonstrate. So you need to just notice some important parts. This question depends a lot on your trigonometry knowledge and a very bit of your skills, you can say, or just you can say observations like that. So you need to make a bit of observation. So what was the equation given? Sec x plus tan x equals 2 cos x. So this is the mother equation. Now remember that the equation you are starting with is the mother equation, and when you manipulate that equation, multiplying, dividing anything from both sides, that is the manipulated equation. Now you must be always make sure of the fact that the solutions that you take out satisfies the mother equation, not the derived equations that you are going through the process. This is because sometimes there are loss of solutions, sometimes there is gain of solutions. So during gain of solutions or during loss of solutions, the problem gets really very hard. So you need to find those solutions tediously. So in this process, what you will get at the end is a gain of solution. To remove that gain of solution and adding of an extra solution, what we have to do is we need to apply conditions. So what are the conditions? So observe this equation very closely. So after observing this equation, just notice that if x equals pi by 2, so if I take x equals pi by 2, then tan x is undefined. So this is a very important observation that was meant for the question, and that's why these questions are favorite for the I.S.I professors. This is because many students forget to make these observations. So if x is pi by 2, so tan x is undefined. So the first step says us x equals not equals pi by 2. So x cannot be equals to pi by 2. Okay? So what I do is now just simple trigonometry method. So I just write sec x as 1 by cos x, as tan x as sin x by cos x, 2 cos x. So 1 plus sin x, so I multiply both sides by cos x, that is 2 cos square x. So that is what I get. And after this I can just write it as into 1 plus sin x. Okay, so that is this. So 1 plus sin x so this is what I get. Okay, now what most of the people do is that they reduce this. So in this problem, this step is very much justified, but in all problems like this step cannot be justified. So I'll explain you why this step is justified for this problem and not for the others. Because as the range of x was given from 0 to pi, in that interval, sin x cannot be minus 1, and therefore I can just cut it off. But if in any case, in general case, sin x can be minus 1 in minus pi, minus 2 pi in those cases. So I recommend you to always check with the 0 condition. This is because division by 0 is a grave offense, and that might lead you to many contradictions. So you all must know this concept, must be aware of this. So what does it become? It becomes 1 minus sin x equals 1 by 2, and then sin x equals to half, and by general solutions with the given range that is given in the question, I can always say that the only solutions can be pi by 6 and 5 pi by 6. And the number of solutions was asked in the question, so number of solutions and according to the test of mathematics book that I always prefer to carry around with me, this is a very important book, so that I prefer to carry with me, the actual option give is option C. So option C is the right answer. So this question is a very straightforward question, I must say. This question does not require any special concept or tricks or tips, just to understand the fact that tan pi by 2 is not defined. So just that. So I don't think that these problems require a very good commentary or a very good concept or a very high funded theorem or a result that I usually do after problem solving. So this is a very straightforward question. So remember that sometimes very straightforward question also appear in I.S.I, so it has happened in past years. So practicing all the hard questions won't yield you marks. So there will be straightforward types questions like these. But the disadvantage is that when you try the hard problems and when you come to these straightforward types, so two things happen. Either you cannot just think it, this is because you have already got the hard mindset due to the previous problems, and the thing is that by seeing an easy problem out of the blue, you just pretend that you have got El Dorado, and what you do is just rush to the solution and make calculation mistakes. So these are what the aptitude that I.S.I papers test in a student. So let's get to the next problem for the day. So it says that if ABC, so this problem is again from trigonometry, but I choose this problem, this is because it requires some concepts in depth. So if ABC belong to R positive and okay, so this is the question that if ABC belongs to R positive and mod C is less than equals to root A square plus B square, then the number of solutions for this equation. So the equation is A sin x plus B cos x equals to C, which is 0, 1, greater than equals to 1, but finite solutions or infinitely many solutions. So I give you some time to try and attempt this question. Okay, so the stipulated time that was meant for this problem is over, and now I'll just go about solving the problem. Before solving this, I'll just make a very notable mention, because that's the trick that is required to solve this problem. You might solve this problem in occasional cases just by substituting random values, hit and trial, or any other methods, but the method I'm going to show you is very simple. So let's concentrate for a bit on this function. So why did I choose this function? You might ask me that why suddenly this function? I could have chosen some other function. This function I have chosen because a sin x plus b cos x equals to c was the given part of the question. So that was the equation that was given in the question to be solved. So I just consider a sin x plus b cos x minus c because it will help me to find the number of zeros of this equation. It means that in how many points fx will attain a 0. So that is what I need to find. This is because the number of points in which fx will attain a 0, fx will be equals to 0, then for that points a sin x plus b cos x minus will be equals to c. I hope it's clear. Now I just try to differentiate this expression. Okay, which further becomes isn't it? So I differentiate this expression, and now we know that for maxima and minima, a cos x must be equals to b sin x. Now since a and b are all positive and a and b both cannot be 0 at the same time, so cos x and sin x also both cannot be 0 at the same time because of the identity cos square x plus sin square x equals to 1. So I get this, and from here I can just say that tan x is a by b, or a equals b tan x. So this can be a point of either maxima or minima. So I just need the double derivative for this. So when I get the double derivative, what I get is a cos x amounts to minus a sin x minus b cos x. So whatever happens, this is always less than 0. So this is a point of maxima. So a equals to b tan x, or tan x equals to a by b is a point of maxima, and that is what we require in the question. Okay. Now what I do is that I substitute this expression in this. So I substitute back this expression in this. So for maximum value, a has to be equal to b tan x, isn't it? So fx, so I just clean the board so that I can get a more exposure of space, and so what we have to do, we have to substitute a equals to b tan x for this, and when I substitute a equals to b tan x, I get b into sin square x by cos x plus b into sin square x minus, I made a mistake here, blunder. So b into cos x minus c. And what I do is I multiply by sin square x on up and bottom plus b into cos square x minus c cos x, of course, so c cos x, and downwards it is cos x, and that is b minus c cos x by cos x. So this is the maximum value of the function. So when I substitute a equals to, so not only that, so I need to find out. So this is not a very appropriate step that I am doing. So what I need is an x such that tan x equals to a by b. So tan x was a by b. So for such x, fx will attain a maxima. So fx will be a maxima in such cases. So if tan x equals to a by b, then fx will be a maxima. So what I can do is that I can just divide, I can just take sin x as some a lambda and cos x as some b lambda. This is because this is just the ratio proportion concept that I am using. So that becomes then a square lambda plus b square lambda minus c. So this is what it becomes. So fx is always less than this value. This is because this is the maximum value of fx, isn't it? So what I do here is I take lambda common and I can say a square plus b square minus c. Okay, so this is what I get. So I take lambda common and a square minus b square minus c. And of course, a lambda must be less than equals to 1. A lambda is also less than equals to 2. So less than equals, sin x is less than equals to 1 and b lambda is also must be less than equals to 1. So after just manipulating, so I leave this manipulating job to you. What I get is that the maximum value and minimum value of a sin x plus b cos x is b cos x, you can say I can just include minus c, is this is max is c by root over of a square plus b square and mean is minus c by root over of a square plus b square. So this is the maximum value that the expression cannot obtain and this is the minimum value that the expression can obtain. And of course, if you remove the condition on c, I can just say that the maximum value is less than or equals to 1 and the minimum value is greater than or equals to minus 1. So this is the condition for maxima and minima of trigonometric functions of these forms. So this must be the conditions, okay, which means that since the maximum, so mod c in both the cases must be less than equals to root over of a square plus b square. And this is the most important concept that I will require. Now since I have got this, that mod c must always be less than equals to a square plus b square. So what was given in the question? That mod c is greater than, just the opposite sign was given. So by this logic that I am using or by this result, you can easily conclude within a second that the equation has no solution. So the number of solutions for the equation is 0. So maximum and minimum value trick and maximum minimum value for functions like these are often helpful in finding solutions to equations, in finding number of solutions when solution doesn't exist. So these tricks help. So I recommend you to use these tricks more frequently and make it a practice or a habit. And now we will get on to the next question. That will be the last for this. So the next question here is question. Okay, so this question is from test of mathematics and it says that the value of this is -1. So this expression is root 3 by 2 plus iota into half is -1 root 3 by 2 minus I by 2, C is iota and D is minus iota. So as usual I give you some time to solve this problem and then before I come back to the solution. Okay, so the stipulated time that was meant for this question is over. And this question is, again I say, another cliche or very clean sheet question that I.S.I has ever posed. So I'm just rubbing it and I'm just doing it. So many of you here might have recognized what this expression is. Yes, and you recognized it correctly. This expression is nothing but minus omega squared. So this expression is nothing but minus omega squared. So all of you, those who are aware with complex numbers, must know what is minus omega squared, and those who are not, so I want to tell you that minus omega square are the complex cube roots of unity. So the roots of x cubed minus 1 equals to 0. So the roots of x cubed minus 1 equals to 0 is 1 omega and omega square, and from here it comes that this root, so omega squared is basically this expression. So minus omega square whole power 165, which gives minus omega, so 2 times 165 it becomes, so 2 5 is 10, so 230, so if I am not wrong, so 165 it becomes, sorry, it becomes 330. So 330, and I just want you to draw your attention. So if I place omega here, I get omega cube equals to 1. So omega to the power any 3 times. So I can just say that omega to the power 33 whole times 10. So minus is the must. So minus omega times 33 is 1. So minus 1 whole power 10 is minus 1. And that is the answer, and option A is the correct solution. So this was just a straight type problem that deals with directly the values of what omega is and what omega square or what are the complex cube roots. So there are no specific tricks or techniques or concepts to solve such problems. So you already will learn in complex numbers or have learned that how these are used. So the complex cube roots of unity. So in this session we have explored quite interesting problems from Tomato. We have gone through various tips and tricks. So I recommend you to solve more and more problems from Tomato. So if you're a serious I.S.I aspirant, Tomato is a must for you, and the second thing that is must for you is study materials from Saurav sir's classes. So those study materials are really useful for I.S.I CMI exams. So I.S.I doesn't always give the questions that appear in Tomato. This is because those questions are the sample problems. So sample problems usually don't come in I.S.I nowadays. So what they do is they try to go questions beyond Tomato. So for beyond Tomato questions, for questions of type I.S.I, that for questions type that goes parallel to I.S.I problems, I.S.I entrance problems, is a bunch of extensive study materials and collections that are based and kept in Saurav sir's classes. So I recommend you to go through those study materials, have a copy of those, go through the study materials and be a topper in the exam. And that's all for this session. So hope your exams go well, and bye bye. Stay tuned till the next one.